sections of lines. When you're given a point and a slope, y equals mx plus b, or you can use that point slope form, the y1 minus y minus y1 equals m times x minus x1. So we're going to look at two of those problems. Emma has 17, and then Connor is going over 23. So we're going to see two of those. We have a little bit more to do with the notes today. We're going to look at a word problem, and then we'll look at a special type of line that only goes through the origin, so it has a special name. So it doesn't have a y-intercept, but it still is a line. So we're going to look at that specific type of line. So just a little bit of notes to finish today. Quiz tomorrow, sections 2.1 through 2.4. There is no formal review worksheet for you to have. So you've got some homework problems tonight to continue to kind of work on writing equations of lines, reviewing a little bit with slope. But I strongly suggest that you look through section 2.1, which was like function, linear. So if something is linear, it should look like y equals mx plus b. If it's a function, each x should have exactly one y. So look over those two sections, like 2.1, 2.2, and kind of review those just by looking through the material, looking at the homework that we had for those sections. So we're going to start with Emma because she has number 17.
So the point was 9, -5, and the slope was -1/3, and we were supposed to write an equation of the line in point-slope form. So point-slope form is y minus y1 equals m times x minus x1. So if you substitute the points for y1 and x1, and -1/3 for the slope, you get y minus -5 equals -1/3 times x minus 9. And then two negatives make a positive, so it'll be y plus 5. And then you distribute the -1/3, so it would be y plus 5 equals -1/3 x plus 3. And you subtract 5 from both sides, and you get y equals -1/3 x minus 2.
Any questions for Emma? Nice job, Emma. You can just put that in like the bin on my desk. That way it doesn't get lost up there. Nice job, thank you. So Connor has the perpendicular problem, 23. That group, the last group of problems, asked you to work with parallel and perpendicular lines.
So the line passes through the point 4, 1, and it's perpendicular to y equals 1/3 x plus 3. So your slope would be the opposite reciprocal, which would be -3. And if you use the point slope form, you get y minus 1 equals -3 x minus 4. And then you get y minus 1 equals -3 x plus 12. And adding 1 to both sides, you would get y equals -3 x plus 13.
Any questions with 23, the perpendicular line? Nice job. Again, you can just put that on the and then block it on there. So there are no problems for tonight for me to assign. Because of having the quiz tomorrow, I'll answer a handful of questions at the beginning of class, but there aren't any presentation problems. In your notes packet, if you'll turn to page 16, please, I'd like to see if you can start the word problem that's at the bottom of page 16. Can you feel it? So looking at example 5, in the school year ending with 1993, 2 million females participated in U.S. sports. By 2003, the number had increased to 2.86 million. It says write a linear equation that models female sports participation. Use the equation to estimate how many females participated in sports. So we're supposed to write a linear equation based off the information that we have in the word problem. What do you need to write an equation? Kevin? We need 2 points. How could you write 2 points given the information? So taking the year 1993 and the number of females participating, I'm just going to use a 2 there. I'm not using 2 million. We'll put that million in the answer when we need it. And then the second number they give us is 2003. And that year is 2.86, or that number is 2.86. So let's make some points. Once you have points, then what can you do? You have now a set of points. Yeah, now we need to find slope. So y2, 2.86 minus y1 divided by x2 minus x1. So the top, 2.86 minus 2 gives us 0.86. And then we're dividing that by 10. And Julian, when you take 0.86 and divide it by 10, you get?
0.086.
Yeah, 0.086. Questions? So what's the second thing you need to do after you have slope? What else do we need to do? Rebecca, do you know? Yeah, how do we find the y-intercept? So you have the slope. How can you calculate the y-intercept? What formula did we use yesterday to help us get that information? So yeah, we can use point-slope formula. So to get an equation of a line, when you have the slope and a set of points, to get the rest of the line, take one of those points and plug them in. It doesn't matter which one. I'm going to pick the one with the smaller number in it. So y minus 2 is equal to the slope, 0.086, x minus 1993. Mackenzie Myers, I saw you had a calculator on your desk. What is 0.086 times 1993?
I got 171.4.
And then if you add 2 to that number, Mackenzie, what do you get?
169.
So a linear model equation models the information that you're given in a word problem. So this equation would represent the data that was given to us about the number of female sports, females in sports. Questions? Okay. So then the next part says, use the equation to estimate how many females participated in sports in 2008. So you have your equation. We've created a model. We want to know how many females participated in sports in 2008. So Brock, what do you think you would do there?
Put 0.086 and multiply it by 2008.
Yeah, perfect. So we know the x value. The year we're talking about here is 2008. So we'll multiply that by the 0.086 and then subtract the 169.4. And Brock, what number did you come up with? Sorry, I'll give you a couple seconds.
1,726 2.88.
You said 1,726.88.
88.
That sounds high. Did you have a 0 with it?
Oh.
Sounds a little high.
172.688.
172.680.
688.
Everybody get that? And this is, what are we talking about? Ooh, female participants. Questions?
Wait, when you subtract 169.4 from that to get how many?
Oh, is this what I'm sorry. Okay, minus the 169.4. My fault. I thought you did that. Let's subtract these now. Sorry, Brock. And when you subtract those two, that number's going to seem a little more real. Yeah. What number then do you get when you subtract those?
3.288.
Yeah. That's better. And that is in millions. The data given to us was in millions. It started out with 2 million, went to 2.86 million. So we'll just make sure we label that instead of actually applying all the zeros to it. So the other thing we're going to talk about is called a direct variation, which is a specific type of line. It's still a line. It's just a special line. So it gets its own special name because a direct variation is a line that always goes through the origin. So it's a line that always will pass through the origin. So any line that passes through the origin is called a direct variation. You will see words, if it's a word problem, that says y varies directly with x. So that would be like the set of words that you would see in a word problem to know that it's a special type of equation. And a direct variation looks like y equals a times x, because there's no b value. So instead of y equals mx plus b, we're eliminating that b if it's always going through the origin. We also changed the slope, because it really is called the variation constant. It's not called the slope, so we changed the letter. So the variation constant is technically the slope. And in this case, it's the letter A. So every line's slope is constant because it rises and runs at the same rate. That's what makes it a line. Up 2 over 1, up 2 over 1, up 2 over 1. It's constant. So for a direct variation, we call it a variation constant, just not saying that it's the slope, the m, because it's a special line, it's a special name. But it really means the slope of the line. So underneath here, it says tell whether the data table shows a direct variation. If so, write an equation relating x and y. And you have a list of data for x and y. What do you think you could do, since there's, I believe, a little graph given, what do you think you could do to help you try and find out if this is a direct variation? If we have a set of points. Julian?
Plot them on the graph.
Yeah, let's plot them on the graph. So if we plot them on the graph, we have to see, will this line go directly through the origin? Does it have a constant slope? Does it go up 2 over 1, up 2 over 1, up 2 over 1 every single time? Because that's what would make a direct variation. It has to go through the origin. It has to have a constant slope. So we have 5 pairs of points here. We can plot those 5 pairs of points. Of course, it goes up to 12 and 15. I only have space for 9. So right now, I have the points 3, -1, 6, -2, 9, -3 graphed. How do we know if this is going to go directly through the origin? If the points we're given right now I have 3 points. Melanie?
You find the slope and see if 0, 0 is
Yeah. So slope is what over what, Melanie? Rise over run. What are we doing for the slope from one point to the next? Just visually, what are you doing to go from one point to the next?
Up 1 over 3.
Yeah, so you go up 1 over 3, or if you start on the left, you would go down 1, right 3, down 1, right 3. So to go backwards, we would go up 1, left 3, up 1, left 3. So as long as you're doing the same thing from one point to the next, it's constant. And if that's constant and it goes through the origin, which this one does, we would say it's a direct variation. So the only difference between y equals mx plus b and direct variation is that it has to go through the origin to be direct variation. If it doesn't go through the origin, it's not direct variation. Or if the slope isn't the same every time. But that has to happen for every line. Like if it's a line, it has to have the same slope. So now this is just a special line that goes through the origin. So this is a direct variation because we're going down 1 over 3, down 1 over 3, down 1 over 3. Or we could go up 1 backwards 3 to get to that origin. The second question says, if so, write the equation relating x and y. Well, if we're writing an equation, we need to know the slope, which I'm saying is a, but really it's kind of thinking of the slope, times x. So Holly, if it's down 1 over 3, down 1 over 3, what does that mean the slope is? Yeah, -1/3. And then x. Which is what we did yesterday when we had a graph and we wanted to write the equation of a line, but it had a y-intercept. This one doesn't because it's going through the origin. Questions? So looking at our second set of examples here, it wants you to decide if the equation represents a direct variation. So now you have a couple of equations here. Last week we talked about an equation being linear. It has to be of the form mx plus b. So now this is just a little more precise. Tell whether the equation represents a direct variation, so it's just in the form a times x. So Odette, what do you think about the first one, y equals 8x? Yeah, that one's a direct variation because it looks exactly like y equals ax. So I'm just going to abbreviate, it's a direct variation. Matt, what do you think about letter B? Y equals 8 divided by x. Why not? Yeah. Because you're dividing, not multiplying. So it's 8 divided by x. We'll actually talk about that type of equation later on in the year. It is a special type of equation. Will, how about the last one? Y equals 8x plus 1. Why not? Yeah, the plus 1. This is y equals mx plus b form. So it's not a direct variation. Questions? So a direct variation, again, a specific type of line. So you have a line, you're breaking it down, being a little more precise. It has to go through the origin. The last example we have is another little word problem. Talking about Hooke's law, which you'll talk a little bit about when you take physics. So Hooke's law states that the distance in inches of a spring stretches, the distance a spring stretches varies directly with the force that is applied to it. So does anybody have a slinky? No one has a slinky? No? Anyone know what a slinky is? What I'm talking about? Okay. One of my girls got a slinky this summer, like an old school metal one. So those are the good ones. And like a slinky is essentially a spring that like you can pull apart, put back together, but it's supposed to climb down the stairs so that like it starts at the top and then it climbs down and then goes down the next one and like keeps flipping over. They're pretty fun. They get twisted a lot though. So what we're talking about here is we have this spring, and force is you pulling the spring apart. It's actually called force, and they measure that in pounds. So the amount that you're applying to stretch this spring or pull the spring apart kind of tells us how wide we could stretch that spring. So for A, it says, suppose a spring stretches 15 inches. So I pulled the spring out 15 inches and applied 9 pounds of force. Write an equation relating D to F. So instead of using an X and a Y, we're trying to use 2 different variables. Up in the problem, it says distance, which is D, of a spring, varies directly. That's like your equal sign. So when you're reading the word problem, distance varies directly is our equal sign. So distance equals the amount of force that is applied to it. So force goes on the other side. So when you're reading a word problem with this varies directly, that's your equal sign. So distance is equal to some number, and that number is going to be A because that's our slope. So we're going to have to calculate that number. So the distance of a spring is equal to some kind of number times the force that's applied to it when we stretch it. It wants us to write an equation that relates D and F when they give us the fact that we're stretching a spring 15 inches by applying 9 pounds of force to it. What do you think you would do with that information to try and write an equation? Abby?
Would you just plug the 15 and 9 into the equation?
Yeah, plug those numbers into the equation. So if it's stretching 15 inches, well, inches gives us distance, so that's the D. We don't know A because we're actually going to try and find that. We want to know what is that slope, what number would be multiplied with the force. Force, it says 9 pounds, so that's that. Plug in a 9 there, not an F. And if we divide by 9, reducing this, keeping it as a fraction, enables us to solve for A, which would be the slope of this problem, or we call it the variation constant. So Abby, if we reduce 15 and 9, what do you get? 5/3. So it says write an equation relating D to F. So my equation, distance is equal to 5/3 times the force that I would apply to it. So that 5/3 is my slope. It's constant with every single spring that we're dealing with. So part B, use the equation to predict the distance that the spring will stretch if you apply 6 pounds of force. So now that we have this constant, this slope, we can find the distance based off a certain amount of pounds that you're applying to this spring. So now I'm only applying 6 pounds instead of 9. I'm not going to stretch it as far since I'm not using as much force to pull the spring apart. And Gala, when you take 5/3 times 6, what do you get? Yeah. And we'll label this with, what is it, inches, not feet. So I can pull this spring 6 inches instead of 15 because we're only applying 6 pounds of force to it. Questions? So you're going to have a couple of word problems when you're reading through the word problem, especially when it says varies directly. Whatever's in front of that goes on the left, and you have your equal sign. Whatever's behind it goes on the right. So just try and think varies directly is like the equal sign in the equation when you're trying to write it. So we have 15 minutes. You have your book with you, you can take it out. If not, there is a whole class set next to Brock over there. Please go grab a book. Just make sure you return it. But make sure you're grabbing the ones on the left side by Brock, not on the right side. Homework is on the board over there. Please copy it down. And you can start kind of reviewing, completing some of those problems for your quiz tomorrow. 15 minutes is a pretty good amount of time to get a good number of problems done. Of course, there's a pass. Make sure you take that with you.